Alright. So, let's look at this problem. Let's look at the left-hand side and the right-hand side. Which one looks like it's easier to manipulate? I'm going to go with the left-hand side. Why the left-hand side? Good question. Left-hand side has fractions within fractions, and this plus 1 that I might be able to add in and take care of, or might end up being a property. Excuse me, a trig identity. So let's work with the left-hand side. And what are we trying to make it look like? What's our vision here? Yeah, so I want to try and make it in terms of sine. So let's start by making it in terms of sine and cosine. So, and I'm going to do that right off the bat. This is sine theta over cosine theta minus cosine theta over sine theta divided by sine theta over cosine theta plus cosine theta over sine theta plus 1. Right? And this is equal to, what do I do now? Yeah, I want to combine my fractions together inside of the fraction. So let's combine these two, and let's combine these two. I need to have a common denominator, though. So what do I multiply here? By sine over sine, and here by cosine over cosine. So if I multiply by sine over sine here, I'm going to end up with sine squared theta. What will I end up with over here? Minus cosine squared of theta. And I know now that my denominators are the same, and they are sine theta, cosine theta. And then that's all over. Let's do the same thing here. What do I multiply this by? This is ending up being sine squared then. And here I multiply by, so I get plus cosine squared of theta. And I know my common denominator there was sine theta, cosine theta. Don't forget the plus 1. So, that might look really chaotic and confusing. However, can we do anything here? What can we do? Multiply by the reciprocal. We have a fraction divided by another fraction. We don't do that. We just multiply by reciprocals. So this is equal to, just write my numerator out as it is. And now I'm going to multiply that by the reciprocal of my denominator, which is, give me just a second, sine theta cosine theta over sine squared theta plus cosine squared theta plus 1. Yes, Mo? To alleviate making the bottom super complicated, could you make that sine theta times cosine theta over 1? And then make it trig identity? Are you saying to write this as 1? Because that's a trig identity? That's what we're going to do now. Excuse me. So right now we're going to cancel out by cross multiplying this denominator with this numerator. And here we're going to write that out as 1. So this is sine squared theta minus cosine squared theta times 1, really, which doesn't change anything. So So I'm just going to add my plus 1.
Are we gonna write the plus 1 and sine plus?
What's that?
Are we gonna write the plus 1 sine plus cosine to get rid of the cosine squared?
Are we going to write
That
1 minus cosine squared theta?
Well, no, write the 1 as sine squared of theta plus cosine squared of theta so we can get rid of the negative cosine.
Yeah, you can do that. That's a really interesting idea. I was gonna change the order of the addition and write this as 1 minus cosine squared theta, which is sine squared theta, or you can write it like you said. Let's do your method. We have sine squared of theta minus cosine squared of theta, but our vision is we wanna write this in terms of sine. So let's write 1 in terms of sine and cosine, and hopefully we can cancel some things out. 1 is sine squared, sorry, that's plus 1. So plus sine squared of theta plus cosine squared of theta, which is now let's combine like terms. Sine squared plus sine squared is and negative cosine squared of theta plus cosine squared of theta is 0. So I end up with my right hand side QED box, and we're done.
Can we put a check?
You can put a check, that would work. It's not a formal proof, so that works.